In this video, we shall derive the moment generating function for the binomial distribution. For more on this topic, you need to subscribe to this channel. First, the moment generating function is given as mxt to be equal to summation as x ranging from 0 to infinity. We have etx multiplied by f of x. So where f of x is the PDF for the binomial distribution. The next thing to do is for we to substitute the PDF, which is this, into this moment generating function. If we substitute the PDF into the moment generating function, we have the summation as x ranging from 0 to infinity, etx, we put down the PDF, which is n x px and q n minus x. So we have succeeded in putting the PDF into the moment generating function. If we watch out, we have something in common here, so we can rearrange this. Rearranging this, we can write it as mxt to be equal to summation of x is equal to 0. We bring this here to give us nx px etx multiplied by qn minus x. If you watch out, there is x here and there is x here, so we can combine them. Combining it, we move over to this other side. If we want to combine this, we have our moment generating function, which is this, to be equal to summation as x ranging from 0 to infinity. We have nx, which is our binomial function. Then we have p et. We bring down the x because x and x here is common. So we'll bring down this x to this place, multiplied by qn minus x. So this is what we have. And we should note that from binomial expansion, we should know that from binomial expansion, we can write as a plus b raised to the power of n is equal to nx ar and b n minus r. So we can write this as this. So it then means that if we have this to be our function, we can also write it like this from binomial expansion. How do we write it? We can write it this way. Of course, we have this. We have nx, which is this, p et raised to the power of x q n minus x to be equal to p et plus q raised to the power of n. All we need to do, the whole of this represents this function we have written down here. Of course, this is equal to this, just like this. If you watch out, the expansion of this and this are the same thing. Of course, if this is equal to this, likewise, this function is also equal to this. Hence, the moment generating function for the binomial distribution can be written as PET plus Q raised to the power of n. So this becomes the moment generating function for the binomial distribution. For more on this topic, you need to subscribe to this channel. If you want to go through this, it is quite easy. Just follow the procedures and you arrive at this. And this becomes the moment generating function for the binomial distribution. For more on this topic, you need to subscribe to this channel.